Greetings, welcome to Self-Assessment 11, Problem 1. So, they asked us to consider the function g of x is equal to 2x minus 4 divided by x plus 5. In other words, it is a rational function where we have a polynomial over another polynomial. And the first thing they ask us is what is the domain? So if we want to determine the domain of a rational function, then what we need to do is take a look at the denominator. In other words, whatever causes our denominator to be equal to 0 are values that need to be excluded from the domain of the function. They're parts of the real number system, but they are not part of the domain of our function. Okay, so what that means is that x plus 5 cannot be equal to 0. What that says then is that x cannot be equal to negative 5. Aha! So what is the domain? So the domain is x is an element of the reals. That's just the cheater's way of writing all real numbers, except x cannot be equal to negative 5. Because when we plug in a negative 5 there, we get division by 0 and the world comes to an end. It's a horrible thing. All right, give the equation of the vertical asymptote for g of x. So one of the things we need to check for is to make sure that g of x is in reduced format. If it is not a reduced fraction, in other words, it's not a reduced rational, then we can't just assume that the values that were excluded from the domain cause vertical asymptotes. But we're in luck. This one is in reduced form. So therefore, the equation of the vertical asymptote is going to be x is equal to 5. Excuse me, negative 5. In other words, when we go to draw that in, we would see a negative 5 would be our vertical line that splits the graph in half, basically. Give the equation of the horizontal asymptote of g of x. Well, the book gave us a very nice trick for that. It says grab the two highest powers between the numerator and denominator. In other words, grab the highest powered term in the numerator, which is 2x. Grab the highest powered term, which is in the denominator, which is x. Form that ratio. And if that comes out to be equal to a number, which it does, that gives you the equation of the horizontal asymptote. So the horizontal asymptote is a horizontal line given by y is equal to 2. Okay, vertical intercept. Well, that's the y-intercept. And remember that if we're looking for the y-intercept, that infers to us that x must have been equal to 0. So that says go figure out what g of 0 is equal to. So g of 0 is going to be equal to 2 times 0 minus 4 over 0 plus 5. When we reduce that, we get back negative 4/5. So giving back our vertical intercept as we always should as an ordered pair, it would be 0 by negative 4/5. What is the horizontal intercept? Okay, well, if we're finding the horizontal intercept, that means we're finding the x-intercept. And if we're finding the x-intercept, that infers to us that y must have been equal to 0. Or in our case, g of x is equal to 0. So that tells us we need to solve the following equation. We need to solve 0 is equal to 2x minus 4 over x plus 5. Well, now the only way that that could have been equal to 0 is if the numerator was equal to 0. The denominator can't make it equal to 0. We've already discussed that, so it's got to be the numerator. So what that tells you is this infers to us is that 0 must be equal to 2x minus 4. All right, so let's add 4 to both sides. Divide both sides by 2. And we get 2 is equal to x. So the horizontal intercept is going to be at 2, 0. Getting a bit cluttered over here, so let me go ahead and clean all of this craziness up here just a bit. So let's see, what's the next thing they want for us? Well, they say what values of x cause g of x to be equal to 3. So that's telling us that they're giving us that 3 is equal to 2x minus 4 divided by x plus 5, and they want us to find the corresponding value of x. Well, a good way to think about this is that we have a fraction equal to a fraction. And whenever you have a over b is equal to c over d, in other words, two fractions set equal to each other, then you can do the old trick called the means equals the extremes. Some people have called it cross multiplying, but I like means equals extremes, so I'm going to call it that. And so if I do that, I get a times d is equal to b times c, and then I can solve the resulting much nicer equation. So notice that is the situation that we have going here. Just need to think about it as being a 1 over there. So 1 times 2x minus 4 is equal to 3 times x plus 5. So let's take this out of here where we've got some more space. Yeah, take it all the way up over here. So we get 3 times x plus 5 is equal to 2x minus 4. Or 3x plus 15 is equal to 2x minus 4. Subtract 2x from both sides, we get x. Subtract 15 from both sides, and we're going to end up with a 19. A negative one at that. So what that tells us is that you plug in negative 19 into our function g, and then the output will be equal to 3. Okay, determine g of 42, and they want us to show all of our work, and then round our answer to 3 decimal points. So to do that, g of 42 says plug 42 in wherever you find an x. So that's 2 times 42 minus 4 divided by 42 plus 5. Okay, now if you're feeling comfortable, you can go ahead and just plug all that directly into your calculator, but I'm going to take a few steps here just for the fun of it. So that's going to be 84 in the numerator. 2 times 48 is 84 minus 4, so that's going to get me back an 80. In the denominator, I've got 42 plus 5, and so if I've got 42 plus 5, that's going to be 47. Okay, perfectly fine answer, nothing the matter with it, but I believe they did say that we're supposed to go ahead and give them back that as a decimal, so let's get our calculator here. So let's see, we got to take 80, and we need to divide that by 47. And we get 1.7, etc. And let's see, they want us to go out 3 places, so this is approximately 1.702. Okay, well, hopefully that was all clear as a cup of coffee, and don't be shy about asking me for questions via the Q&A form, or you can ask me a question directly as from my message.